thank you for that very, is this on? No. There we go. All right. Thank you very much for that kind introduction. I know I only have 10 minutes, so I'm going to make this really fast. The name of my talk somehow, maybe probably my fault, didn't make it into the schedule in time, and I appreciate everyone showing up anyway. But I actually struggle with this a bit because I do a number of webinars kind of as a CTO, and like there's a lot of things I do talking to customers and whatnot. But it's been a while since I've done a community talk, and so coming back from the hinterlands of customers and money and all that stuff, thinking about what are the things, what is the message that if I have a chance to speak to fellow Pythonistas, what is the message that I want to send? What are the things I've learned and whatnot? And especially because this particular instance, so this particular conference actually marks the 20th, according to Leah, it's the 20th PyData conference, right? So that's really amazing, and as Brian said, it comes together because of the hard work of volunteers, all the speakers that work very hard on their talks and the content, all the tutorial presenters, everybody works together, and it's just been amazing that in 4 years we have put together 20 conferences and hundreds and hundreds of talks. Only 230 or so are thumbnailed here, but there are lots and lots. And there'd be more if we could find a few of the ones that we lost, right? As Jim said, yeah. So in a sense, I wanted to sort of always look back to see where have we, how far have we come, where did we come from, and really, what's changed in the 4 years since we started this as a little tiny workshop, at the Google campus. And a lot actually has changed. I would say that one of the biggest things is that now versus, so 4 years ago, 2012, there's a lot fewer of this R versus Python stuff, right? And I think that I would like to think that it's because Python showed up and just dominated so hard there's no point arguing anymore. But because if it really sucked, there'd be a lot more of it, and then it would fade away and R would win, right? But actually, I think what ends up happening is as people started using both of these things more and more for real work, they stopped arguing about stuff and just kept using the tools and making the tools better, and it sort of ceased to be an issue for most people. But of course, now we also get the Scala versus Python thing, so we won't, not get into that until later. But actually, one of the things that definitely I think has changed, especially in talking to customers and being out in kind of big data industry conferences and things like that, is that that it's clear that Python and R, it's clear to me, and I think it's clear to most people, that Python and R are here to stay, right? So many people who are teaching data science, like Galvanize and so many others, the curricula are based on Python and R. I mean, it's like, what else are you gonna do, right? So that's a really, really powerful statement, I think, about just, these are here to stay. This is basically what's here. And so kind of tied to that, Python's become sort of normal in the space. And for those of you who are somewhat maybe new to this ecosystem or to the community, that wasn't always the case. In 2012, there was a lot of, and for years after that even, there was sort of like, well, but Python's just the scripting language, right? Like it's the slow scripting language. There's a GIL that makes it really bad. And so why are you using that thing? It's, maybe we'll use it now, 6 months later we'll replace it with something more real. And that kind of conversation has also gone away, that so many people have looked around and the peer validation, the fact that there's so many companies just doing real stuff with Python, it's become normal in the space. And in fact, deep learning, I would say that Python is like the dominant language in deep learning. It's a very exciting new area of data science, machine learning, and automated statistics. And all of the papers being, not all of them, but many of the papers being published, the new algorithms being discussed, new libraries, they all have Python embedded in them or are implemented in Python. And additionally, one thing that here in the PyData community, as we're talking about Python's applicability for data science, we might, compartmentalize just that thinking, but a thing that's worth bringing up is that in the scientific Python and the HPC and engineering simulation side of things, Python's dominance there continues, the momentum continues and accelerating. Excuse me, too much coffee. So the general idea here is that across the board in the last 4 years, we've seen an accelerating adoption of Python, and that's super exciting. And again, is due to the hard work of a lot of volunteers in the community. The Python community is not that commercial, and so there's everyone that's pushing that forward. They're pushing it out of a somewhat self-preservation, but also out of a love for the tools and technology, I think. And one of the things that also maybe is somewhat of a controversial statement, but I don't shy away from those. But I would say that in the last 4 years, what we've seen is really when we started Continuum, clearly Hadoop was at the peak of its ascendancy, I would say, and now sort of the first age of Hadoop is drawing to a close. And that doesn't mean it's going away, to be clear. It's here and it's still growing, but the first wave of that, the Gartner hype cycle, we crested that wave, and that happened in the last 4 years, and that's changed the conversation for us as Python data scientists as well. So the other thing to note, of course, is that whenever there's a first stage, there's a second one, right? And I would say the second stage is not yet here. And what I mean by that is that when I think we'll see kind of in some later slides, the second age of not just Hadoop, but of kind of the data, all this data revolution type stuff, that I think will be here when we see people thinking about the bandwidth between storage and compute as being the first class concern as opposed to merely capacity or CPU speed. And that's, I think, going to take probably another 2 to 3 years for it to really hit mainstream. But the inevitability of that happening should be clear to most people that are working in this space now. So that's things that have changed in the last 4 years. I think it's actually more interesting to talk about what hasn't changed. One of the things that hasn't changed is that data is everywhere, and there's just more of it. It's messier, and that just continues. It has not changed at all. We could put it all in Hadoop. It still is messy, right? So it doesn't really solve the problem. So the other thing, though, around data being everywhere and growing is that actually the data is not even the hardest part of the problem. And the thing that we've seen over the last 4 years that I think makes this more interesting is the fact that everything around the data is also changing at the same time. So not only are we debating SQL versus NoSQL, not only are we debating different kinds of technologies for the data warehouse and architectures, but all of the stuff around data is also changing, and that's the compute, the hardware, the analytical routines and algorithms, everything around data is changing. And I'm going to go through this a little bit more quickly, but the idea here is that for the last 25 or 30 years, we've really existed in somewhat of a monoculture at the lowest levels of infrastructure technology. The x86 instruction set and Intel's chips being dominant has been the way of the world for 30 years. There's other stuff too that's kind of around, but for the most part, in business computing, x86 was it, and then if you're talking about business computing as well, then Windows was the dominant platform, and then only the last 10, 12 years has Linux really ascended into a mainstream position on the server side. And again, there's other stuff there, but for the most part, we've lived in a period of relative monoculture relative to before the previous 30 years. There was just everyone was cobbling hardware and software stuff together and trying to make custom languages and custom network stacks to do all sorts of weird stuff. So basically, most of your devs in the last 30 years, they basically were going to write some code in Java or .NET, deploy onto a pretty standard backend. They didn't have to think about weird things like NUMA. They didn't have to worry about cache coherency. Those are things that maybe people doing exotic cluster computing would worry about, but your mainstream person only had to worry about the top part of the stack. What we're seeing now, of course, is that the whole bottom part of the stack is blowing up. And so, for instance, we have GPUs. Many people here in this room, I'm sure, are playing with or experimenting with deep learning. And that right there is 5 teraflops on a chip, right? That's, I think, the Pascal chip. We have Amazon AWS and other cloud vendors actively encouraging us to stop thinking about computers as a box with a CPU fan and hard drive, but rather to think about actually doing a software-defined, cloud-scale, cloud-first architecture for our information system, right? And then, of course, because we're blowing up the lower end of the stack, that also means we have to kind of muck around with what an operating system is or is not, or gets wrapped in another operating system, whatever. And if you think about all this disruption, kind of all this stuff happening, Hadoop, as I've mentioned, Hadoop is actually just one instance of this disruption happening in a particular niche, which is the data warehousing niche. And so this same thing is happening on every single other aspect of business data processing. And so, instead of thinking about all of these different, this traditional stack, we now have to think about, we're encouraged to think about a much more deconstructed set of technological Legos. And the reason why this matters so much for analytics is that actually all the stuff we tend to use or run into is really old. Like even NumPy is quite old at this point. And all of these things were built on top of that traditional single node kind of paradigm. And so in terms of what hasn't changed is that the stuff is really old. It's maybe 4 years older now, but it's still really old. And what hasn't changed is that all of this stuff continues apace, right? But again, more stuff is coming down the pike. Okay, so does anyone know anyone who's not a Continuum know what this is? Picture of. Well, okay, some kind of semiconductor device, right? So this is basically, and actually that's the best I could say, because it basically looks like memory, right? It doesn't look quite like a CPU, but actually it's a thing called 3D X-point, and it is not like memory because it's persistent. So it's persistent storage, okay? So it's kind of like an SSD, but it's 1,000 times faster than SSD. So it's basically like memory, but it's not like memory because it's 10 times more dense than memory. So your 1 terabyte or 2 terabyte of RAM server that you have under your desk, hopefully, that thing is going to be able to go 10x in terms of density, and you never have to free your memory because it's just like a malloc is a write, and so it's persistent memory class storage, and this is coming down the pike. So the hardware kind of level disruption that's happening to how we think about operating systems and compute and all that stuff is only going to accelerate harder, right? Oh, by the way, they're going to make this available, I think, for GA in 2017. So you'll be able to plug it into a DIMM socket. You'll be able to plug it into an NVMe class like SSD storage. I mean, you can do a lot of things with it. But this is an Intel and Micron joint technology. But the basic idea here is, for those of you who are kind of not maybe like software developers, what this kind of thing means is that you never have to quit an application. So your applications, they come up and they kind of hang around. They create stuff in memory and it just sits there. And so that kind of rethink, I mean, that's never been the case as long as I've been programming. I've been programming for a while now, right? So this idea that you don't need a save button, all applications are always running for all time, fundamentally changes how we think about processing, how we think about data architectures and infrastructure. All of those things change, right? And so I guess to kind of wrap all this up, what hasn't changed is that we are still just at the beginning of the data revolution. We're just at the beginning of it, even 4 years later, because that wave is so big. We're still at the very early stages of that. And that the technology innovation, though, is accelerating. It's definitely getting faster and faster. People who maybe 4 or 5 years ago thought like, oh, if I just get the Hadoop and I go on the cloud, I'm good. I'm going to be good for a while. But actually, no, it's going to get worse and worse and worse. So every aspect of how we ingest and how we store and how we manage and process data is going to change from here on out. So actually, probably 2 or 3 years from now, you'll look back and maybe more and more people will start realizing, the 80s, 90s, early 2000s, that little unique period of monoculture, it was an anomaly, actually. And that when we have so much that we could be processing on data and we have so much data to process, and so many different Legos to put together, we actually have to kind of like think again about how we're going to put this stuff together and be very thoughtful in our engineering around information systems. But with all of that kind of technology, let's say churn, right? We might ask, well, how much of this is actually innovation? How much of this is just churn? Because it's clear, obviously, there's a new open source project in Hacker News every day. Like data technology is like extremely noisy and confusing, especially so if you're not a technologist per se, but you are a buyer, right? If you're a customer, if you're a manager, in some business, you're trying to figure out what database is it this week? It's named after some goofy sci-fi character, or is it named something, whatever? Like I don't know, but I guess so. I guess they use it Twitter, so maybe it's good. So that kind of thinking, right, is very confusing for people. It doesn't make them feel good, and we laugh about it, but it's not great to have to be in that situation. And so the fundamental truth is that the innovation and the disruption is real. And if it forces you to think about your fundamental problems, that's good, right? So you're like, wait, what am I doing here? Why am I doing that? Why are we doing this thing over here? And you kind of drill down to the bedrock of what is my actual problem. That's great. So keep doing that, and you'll at least track to something relevant to your actual problem. The opposite of that are Band-Aids on Band-Aids on Band-Aids. And generally, the way that works is a vendor comes in and says, hey, if you do this, you don't have to worry about this anymore, right? Great sale when the bedrock is not like shifting around. There's not an earthquake going on. You can just do that. You can just keep putting more and more stuff under the rug. Nowadays, though, what you end up doing is buying into stuff that then next year changes, and then next year will change again. And so you're just kind of on this cycle. And so this general kind of dichotomy because I get some of this feedback sometimes when talking to people about this concept, is like, oh, there's so much churn now. Just like, I wish I could just call somebody up, call my rep up at IBM and make it all go away or something, right? And the problem is the rep can't make it go away either because they're in the middle of it, right? Everyone is trying to figure this out. So it has to be, you have to insource that knowledge. You have to actually think about what is the problem I'm trying to solve. And not just, can I solve it with this new thing I read about on Hacker News, but actually, fundamentally, what is the problem I'm trying to solve? At the data level, at the computational level, so thinking about data movement, thinking about bandwidth, thinking about all of those different things. And if you think about that, then you start gaining skills as individuals that are going to be relevant across many different businesses, many different sectors, because everyone's going to have basically fundamentally the same kinds of afflictions as we go into this new era of big data. So one of the things that I encourage then is that in the short term, you should be pragmatic. In the long term, you have to be strategic. You might say that's kind of tautological because strategy is long term, but fundamentally the insight here is that people change and learn slower than machines do. So if you're going to invest in people, then make sure those are long-term investments. If you're going to invest in people, make sure those are long-term investments. Make sure they're learning technologies that are going to be relevant for the long term. Make sure they're learning about problems and approaches that are relevant in the long term. The infrastructure and the code, the things you build out today, are going to change in 2 years. Almost certainly they're going to change in massive ways in 2 years. So now is a great time to think about what parts of my problem are deep, what are fundamental, how do I hire the right people and give them the right skills to, over the long term, be able to solve this problem? Not merely, hey, I need 10 Python data scientists, 2 R guys, and 5 Scala programmers to deploy the Spark thing, and then next year, maybe, I don't know, we might move to Cassandra, Spark and Cassandra, but yeah, that's what I need right now for the next 6 months. And so, like, that's not the right mindset. But people do literally think like that. We can laugh about it all we want to, but the big admonishment here is to think about technology, short-term, pragmatic kind of things, but people who know how to architect that technology, those are long-term sort of investments, long-term sort of folks. And so I've been talking a lot here, even though this is kind of community talk, I've been talking a lot about business adoption of Python, and that's because that's kind of my lived experience for the last while now. So I've done a talk like this before about Python meeting the enterprise. It was a really great lightning talk. But I want to do this again kind of more formally, and this is the 2016 edition, essentially. Basically, the big thing here, the big concept about Python in the enterprise is that people always fundamentally misunderstand Python. Like, I've very seldom walked into places where they really get it. And the reason is because it's very unique. There's, I would say, no other language that's like Python in the ability to actually span multiple different tribes of usage as completely as Python does. So, the really hard thing for data science is that if you put a data scientist in front of a computer, or a Python shell or Python editor, and you put a Python software developer in front of a computer with a Python shell and a Python editor open, to the manager, it looks like they're both coding, right? But they're actually both, and we're laughing here because we know they're doing very, very different things, right? And so the Python developer, the web developer or whatever, like, they are getting paid to make code. That's what they do. The data scientist is trying to write as little code as they absolutely have to get to some analysis, some analytical insight. You know, that's what they're getting paid for, is not to generate a whole pile of code. They might have to as a faster means to getting to the insights, but that's ultimately the big difference here. And businesses are not actually equipped to think in this way. That they tend to think about, and this idea of pigeonholing, they tend to think about, if you're typing code into a file and you're saving that file and checking it in, you're a developer, and the developer's in the IT organization, and here's what we use in IT, we use Java. Or if you say, well, no, actually we're doing predictive modeling, and there's analytical insights, and there's a logistic regression. Oh, great, you're an analyst. Well, here's your Excel, and here's your SAS, right? So this kind of bifurcation is how businesses have thought about this for a very long time. And they can build these silos on this foundation that's not moved in 30 years, but is now finally starting to fracture in a fundamental way. And you see this a lot when people deploy Hadoop and they completely they give schema on read, their entire data architecture, data warehouse changes, and now they have no idea what to call different people. You know, your Scala Spark guys, are they data scientists or are they data engineers? The Python people coming in with some scripts to munge some stuff, do some ETL, are they a data engineer or are they a data scientist, right? Like, if that ETL code in the middle of it calls scipy dot, you know, something, it's not really ETL anymore, it's some other shit, right? Oh, sorry, some other stuff, right? And so the idea is that the traditional ways of pigeonholing these folks is falling apart, as we're changing out the software and the hardware infrastructures, and as we bring in people like yourselves who are equipped with skills to be cross-cutting, right? So you go in there and you're just some kind of ninja, and it's like, well, would you want to be an archery ninja or a sword ninja? You're like, I don't know, but I'm just a ninja, right? So this idea, but you laugh, but it's actually a problem for people. Because if you go and try to get a job at one of these places, they're gonna say, do you want a sword or do you want, a bow? And you might want both. And it's like, well, we don't have that, right? So it's really, and this kind of, it shows up in the broader communications and the broader kind of discussions around this stuff too, because I just ran into this particularly exceptionally annoying blog post not too long ago. And this guy, it's really interesting. I mean, I don't, his lived experience is his lived experience, and I will not denigrate that. But the concepts that are being pushed here, I think, really fundamentally speak to the kinds of problems that arise in businesses around this. So basically, I'll let you guys read a little bit. Basically, he went, I guess, PhD, mathematics, stats, whatever, trying to find a data science job, going in for interviews, and makes the claim that he called up 50-something companies, got 24 interviews, and with a few exceptions, Python was clearly frowned upon for a data science job. And no one ever told me I couldn't use Python, but his, I didn't put it here in the quote, but in one situation he was asked a question that required, ideally the use of a heap, but heap is not built in, and so he wanted to use, I think, heap queue or something, but that wasn't installed in the interview environment, and so it was awkward. Now, if they were using Anaconda and giving him Conda and network connection, it'd be done. But the point is that this idea is what I see in this, and this other thing that's really interesting. Well, I'll get to that in a second. But the idea here is that if you go and interview for a data science job, if that data science job is being put out there by the IT department, it's going to be a different kind of data science job than if it's put out by some business analyst or line of business, right? And so. The other piece of this that's interesting was he said, I decided I would learn some, he learned some Scala, and he decided to use that in the interview process, and I just absolutely love this. The interviewers actually encouraged me to use Scala even when they were not familiar with the language. They would trust the REPL to audit my code, and they would, I guess, use the time to address more general points. Okay, but then they would follow me on Twitter. So this is a real phenomenon, right? And there's nothing wrong with Scala as a language. There's nothing wrong with clearly Spark, Scala as a technology stack. It's just this general confusion and haze as businesses try to move into modern data science, I guess. And what they suffer, and this little following my Twitter, and I don't even know this language you're using, but I read about it on Hacker News, it's really cool, and so you must be more awesome than me. That is what I call the open source head fake. And it's a real thing now, and there's billions of dollars attached to this, believe it or not. Like, it's a real thing. And what I mean is that businesses, when I go to businesses, or I hear from businesses that they want open source, they're interested in open source, there's basically 2, maybe 3 reasons they're interested in open source. One of them is because they're tired of lock-in, vendor lock-in, proprietary stacks, proprietary technology. And also, it's harder for them to harness innovation. So the brighter, more clueful businesses have moved on to using open source, and they recognize that they're able to tap into newer things faster rather than having some stodgy old vendor kind of gating them. And the other piece is that they recognize there's a serious talent war going on, especially on the data side of things. And so if they're using open source stuff, they have a better time recruiting. So those are the 3 primary concerns I've heard, basically. But what ends up kind of getting lost in the noise in this conversation is that people don't, I don't know why, but they sort of not realize that open source is not just about slapping a license on a pile of source code. Like, just because someone can give you a source code dump, you've got nothing. It's like free puppy or free truck full of puppies, right? All the big jar, puppy in a jar. No, that's not valuable, right? Actually, what's valuable about great open source is that there's a community of people that either have come along to support it or that created it. Usually it's a few key people solving their own problem that also can code, that create that first little, the inception of the project, and then it spreads and it gets adopted by a community of people. It takes a village essentially to raise real open source. And that is sometimes lost, I think lost by many people in the community itself, not our community, but overall in the software development community. And other times businesses actually don't get it. They sort of can't tell some open source from some other open source. It's kind of like if you go to the grocery store and you're buying organic. Everyone knows they want organic, but like if it's spelled wrong, if it's like printed with, well, anyway. The point is there's real organic and there's the organic that sort of is like And so here, I think in open source, we see a bunch of that. People are using the prevalence of social media and online communications to actually turn open source into, they proxy a bunch of other stuff on it. It becomes a self-promotion tool. It becomes gamified. It's, all these other things. And it's not, well, it's whatever it is. People use the internet however they want to. But for businesses trying to consume better innovation and better, more innovative software, and for people like us who are users of that software, it matters a great deal that we have good stuff coming in, right? So one of the things that's really important about this that I realized is, and maybe an obvious point to many of you, but something that I've finally been able to put words to in the last year or so, is a corollary of Conway's law. So just for those who are not familiar with Conway's law, it was a guy came out with in like 1960s, 68, something like that. And it said that any piece of software reflects the communications structure of the organization that produced it. If you hire 3 subcontractors to build a piece of software, you're gonna get 3 components in that software, right? And so there's a corollary of this that I've discovered, or whatever, been able to put words onto, which is the idea that business data architecture ultimately evolves to reflect the budget structure of the IT people that maintain it. It is not optimized for strategic and long-term operational needs. It's not optimized for ensuring future agility. It is certainly not optimized for generating insight. It is optimized so that some IT guy is able to say, here's how much I spent on licenses for this part of the database, that extension, this little Excel add-on, and this other thing over here. And by IT, I mean also the software groups that usually fall under the IT budget of people that build internal data systems and internal business applications. And this concept that basically businesses have optimized to buy technology, existing or legacy technology in a certain way, it means that they have a hard time consuming new innovation even when it's free, even when the licensing cost is 0. They don't actually know how to operationalize that, how to build accountability structures internally. And so the admonition I give to them is, look, don't starve the unicorns. Everyone says data scientists. You guys are here in San Francisco. Statisticians in San Francisco as data scientists. So if you want to get those unicorns, once you get them in the door, don't starve them, right? The way that businesses tend to buy actually pushes power away from data science capabilities, because data science is an incredibly cross-cutting thing. It's very exploratory. It's very experimental. It is science, right? You have hypotheses. You're gathering new information. You're integrating things, and you're trying to come up with more powerful explanations. And so information systems have traditionally essentially ossified now into just software, hardware. I got a data center, maybe it's moving to cloud, I got these different pieces of software, I stitch them together. And for data processing, that's fine. Like that's okay, you know what data is coming in, you know what you want out of it, you can make reports, you're all good. But if you want human in the loop systems where you're actively coming up with new ideas and you're actively drilling into new areas and you're trying to do all this crazy stuff, you're producing, you're doing inference, you're producing inside knowledge. That is not a traditional, just like straight through business data processing problem. And so the architecture of how you even do that is a new discipline for businesses. And so, I mean, the way that it's interesting, once I came to this understanding, I was like, oh, well, that's why they're not getting it. Because they think they can take the unicorn, stick it over here, and treat it like a cat. But it's not really a cat, And but it's a bit of education. To convince businesses to actually go and change how their budget structures are is very, very difficult, and it takes time. But many of them are starting to come around now, which is great. And that brings me to my talk, which is Python for Pythonistas. Now, actually, So at the end of the day, though, I'm often led into sort of these conversations about advocacy of like, why do you use Python? Why sometimes there's data scientists there who are like, of course we're using Python. Don't bother them about that. Ask them this other stuff, right? But I think it's important for all of us to be able to articulate well the core value proposition in Python. I think that for me, the way I've always thought about it is that it's about empowerment. That it is not just technology for technology's sake. It is not just another churn of the technology wheel. It's actually this idea that we can empower smart individuals who understand some domain problem to go and access all the data and to access all the compute that they need to go answer those questions and come up with better questions, more importantly. And this is actually, it's worth noting, this is actually very unique in the history of technology. That technology usually, when it gets powerful and valuable, it quickly specializes into a specialist race car, a specialist airplane, a specialist thing, and then you kind of have this hyper-specialization evolution of people who are able to drive those race cars and airplanes and everything. But Python is actually extremely generic tooling. And so that's a challenge for businesses, because now if every single data analyst who, they might not be happy about the fact that so many of the insights come out of Excel, but at least they can manage a floor full of Excel analysts. But if you give that floor full of Excel analysts the unlimited power of the entire Python stack, or R, or Spark, or whatever, and you give them access to all this data that they should have access to, and they understand the business problems, think about what they could do. It's enormously disruptive, and businesses don't necessarily operate that way. So it's almost like, again, the free puppy thing. You get a unicorn, now what are you going to do with a unicorn in your kitchen, right? So this is the problem, that actually operationalizing the human change that means has been a process for them. But, however, I think it's extremely important for us as Python users, as Python committed folks, that we are able to recognize that challenge and articulate why it's important to take that step and overcome that hurdle. So to wrap this all up, PyData is only 4 years young. We're going to be around for much, much, much longer. A lot of great things to do still. And if you're here, whether you're PyCommitted or PyCurious, you're all part of it. You're all part of that community, all right? And so one of the things that I think to point out is that actually the fact that we have so many people who are new. How many people here is this your first PyData event? Holy cow. That's awesome. Thank you guys so much. That's awesome. Thank you so much for coming out on a weekend on this just like terrible weather in San Francisco and hiding away in a basement. But actually, it's really important that I think the Python community as a language big tent community, it stresses openness, it stresses being welcoming and diverse, and it really stresses the education and the onboarding of new people into the community. In PyData, it's no different. And in fact, I would argue that because of the unique position of what Python is, that it's both a user language as well as a software development language, if we don't constantly get a stream of new users coming in telling us, I don't know how to use this, or I don't see why this is put together this way, if we don't get that, then we actually are going to suffer the problems of ossification. We will be vulnerable to the problem of being an echo chamber where we're making cool things for ourselves and then everyone else is like, what's that weird stuff, right? So the new experiences and the new perspectives, the kind of newbie questions of like, oh, forgive me for being a newbie, but why does this do this? Those questions are features. Like that perspective is really important for us as a community. And I think every single, you look at the list here, all of the different projects in the Python, in the scientific Python, the PyData communities, all those significant projects that have taken on a certain amount of momentum, they all really appreciate that kind of input. And that input is what's made them powerful, I think, and really relevant. And so 2 years ago, I was at PyData, we had PyData Silicon Valley down in Facebook, and I had this slide where I said actually the single most important thing is fundamentally still community, right? And that absolutely has not changed. This idea that it is a community of users, a community of makers, a community of actually nowadays vendors and buyers and recruiters and employers and everybody, it is a vibrant community of people. And that's actually really, really critical. And that ensures our relevance even as technology is changing out underneath us, even as we make new things and adapt things to old things and all this other stuff. As long as we actually take care of the people aspects, then the technology will sort itself out. So I would encourage all of you, those who have been here in the ecosystem and the community for a long time, to keep doing what you're doing. All those who have volunteered their time to organize events like this, those who are prepared who have prepared talks, thank you, all of you, for what you do, and I encourage you to do more of it. And all the people who are new to this stuff, I encourage you to participate, be active, make your voice heard, contribute in whatever way you can. We actually feel that the community part of Python, PyData, SciPy, that community is the single most important feature. Many people have said about Python that they came for the language, they stay for the community. And I think for PyData, it should be no different. So thank you very much. Do you have any time for questions, or?
Yeah, you got a couple minutes.
Couple minutes. Any questions? Yes.
What do you think it would take for companies or businesses to understand, to get it, to understand Python?
So for businesses to understand Python, the ones that have gotten it the most that I've interacted with are ones where they recognize that what they generally do is they recognize that data science capabilities are not only radically above and beyond in what their current infrastructure is, but that their organization can't absorb it. So they've actually recognized it. And at an executive level, they bring in someone who is a head of analytics or chief analytics officer that goes and creates, maybe tied to the CTO office or something like that, and they create a a center of excellence or some kind of like cross-functional like tiger team of people. And those people go and they actually kind of do that internal transformation. So for big businesses, that's what I've seen. But the other thing is that there's a tremendous amount of influence wielded by those participating in social media. So many people in corporate America are firewalled off and cannot go and participate in the discussions. But if you tweet at all about data science, your tweets are going to get read by dozens and dozens of people that are actually influencing decision makers in the space. It's kind of a weird thing because in traditional enterprise software vendor, whatever kind of things, people pay a lot for that influence, right? I mean, we pay to show up at Gartner. People pay to be in all these different kinds of things. That influencing technology decisions is a really big business. But we're seeing more and more businesses actually being transformed by input from kind of social validation, kind of peer validation by practitioners, as opposed to simply like, what vendor rag did I read that said this, and I'm a CIO, so I should buy this. Like, that's happening. It's a natural, organic process. Great question. Any other questions? Yes. Mm-hmm.
Sometimes they get it, sometimes they don't. I'm wondering if you like give resources for me to learn how to better get that across.
Yes. So the question is, I just recently started a company, and I'm trying to convince them and show them how using scripts and using kind of more programmatic approach to analysis is more powerful and better than Excel. And well, don't laugh. Don't laugh. A lot of the world runs in Excel. So, and it's a real question, right? Because it's easy for us to get into this very like, oh, holier, like not higher than thou sort of thing, where because I can write a script to do what you do in 10 minutes, and I can like that. It's very easy to kind of get in this mentality. But actually, I would say the best way to do it, like if I were in that position, I would find the people who are most respected in that tribe of Excel people. Find those people, find what's killing their day. Like I used to know this lady who worked at an investment bank who had a 4-year-old HP laptop that would get locked up for 2 hours every day because she was doing a gigantic VLOOKUP to different 2 million row spreadsheets, and it was an n squared process, right? It's for each row VLOOKUP the other table. For the next item, VLOOKUP the whole and I was like, so literally this is a set intersection of two, I mean this is built into Python. You don't even need to like this Scala guy. You don't even import anything to do a set intersection, right? And so the ability to write a small script and solve her 2 hour a day of no computer problem really helped, right? So those are the sorts of things. I would say it's extremely tactical. It's winning hearts and minds. And as opposed to persuading, kind of just help, right? Because if you are so incredibly badass with your Python, you should be able to make their days much better, right? So do it. Right, and I would say that's where the proof is. I'm not, no, but I'm saying like the proof is in the pudding there. So if you, learn some of the Excel plugin type things, show them how much better the graphics can be if they use Jupyter notebooks, they use things like Bokeh. You can do some really cool stuff that they just can't do in Excel. And so, so while you may be proceeding strategically from the perspective of long-term, this is of great value to our company, in the short term, the hearts and minds thing is about winning that tribe of people over. And a lot of times, it's just about curing their daily pains, especially relative to Excel users. Do we have any more time? We're out.
I think we're out.
Okay, we're over time. Thank you, everyone, so much.